there are quite a few possible finishes out there, depending on who's made the laminate. These are the two most common. If you don't say anything to your fabricator, you're going to get reverse treat, which is called RTF. And what that's about is, I touched on it a little earlier, we deliberately rough up the surface so that it bonds to the resins during lamination. So reverse treat is the default. There is VLP and HVLP. Those are really the same thing, depends on who's doing it. Very low profile. Again, if you don't say anything, you're going to get reverse treat automatically. Again, the reason for reverse treat is adhesion during lamination. When you get to above 2 gigahertz, the roughness of the copper is higher than the skin depth of the current. And so I've got this slide to show you. So part of what we did in that test board that with Isola is I had a 16-layer board with 6 strip line layers. 3 of them were made with rough copper and 3 were made with smooth copper, where they had the same exact length in both of them. So that the difference between just the copper was measurable. That's what this is. So this is an 8-inch trace where this is the loss with very low profile copper and this is the loss with reverse treat. And you can see that at 8 inches out to 6 gigahertz, you really can't tell. And the reason I'm sharing this with you is you might be concerned about this, and so you ask for very low profile copper when you don't need it, because that comes at a premium. It's also not very widely sourced. And so until you get out around 12 or so gigahertz, above 10, which means 20 gigabits per second, until you get out in that region right there, don't worry about the roughness of the copper. And for everything that you told me you're doing right now, it's never going to be a problem because you're down in this region right here. If you were doing PCI Express Gen 4 and you had a 30-inch path, you would worry about it.